Hello, my name is Maeve, and today I will be talking about the correlation of drylines over an area to thunderstorms being reported in that METAR. I'm interested in this mainly because I work in a career that is particularly vulnerable to changes in weather, and I work at Cannon Air Force Base. That's me in the picture on the screen with some of my friends after we flew one of our flights. Behind us is the plane that I fly. You can kind of see some good weather coming in as well. Where I live in New Mexico, the locals around here talk about how it's always avoided by the rain, how it will rain other places but never here. And then when it does rain, the thunderstorms are very intense. And from my perspective, landing and taking off out of Cannon Air Force Base is always a challenge because it has frequently really, really gusty, kind of warm weather that can cause crosswinds and variations in our speed and the way that we land and take off. Essentially really, really challenging conditions for us. All right, so what is a dry line? So dry lines are boundaries that essentially separate a very moist air mass from a very dry air mass. And usually that moist air mass is maritime tropical air from the Gulf, and the dry air mass is from New Mexico, from western Texas, from northern Mexico, and when they bump up against each other, they create that sort of like a boundary, and you can see it on surface maps. As you can see from where the yellow star is in this PowerPoint, that's where Clovis, New Mexico, which is where Cannon Air Force Base, where I live currently, and where I work, is located. That dry line can move northwest and southeast, obviously, and for a lot of the year sits very close to, if not directly over, Clovis and Cannon Air Force Base. So we talked about some of this, right? The dry line's the boundary between the maritime tropical air masses, usually from the Gulf, and the desert southwest. They develop in the Great Plains, oriented usually east-west, oriented usually north-south, and it's pretty coincident with the terrain that's also in the western U.S., and that can be where you get a lot of those dry air masses as well. Inversion usually marks like the upper boundary of the dry line, and normally that shows you kind of where the dry line ends. So the end of that inversion on the upper levels is also the end of the dry line horizontally on the surface. So why are we interested in dry lines? Like, what does this mean for us? In general, there's been a lot of research over the years that shows that dry lines can tend to be associated with thunderstorm formation, and that days that had thunderstorms usually also had a dry line occurrence. And many studies classify dry lines differently. Schaefer uses dew point and temperature and diurnal changes in the temperature gradient, but in general, a pretty common method to classify a dry line is looking at a surface moisture boundary that has a specific humidity or a mixing ratio of greater than 3 grams per kilogram of moisture gradient deviations. This is the metric that I will use in this study when I look at the METAR data, but just know that there are more complicated and more in-depth ways to identify a dry line. So there's been some studies about dry lines in South Africa, as well as the National Severe Storms Project staff did some studies about boundaries of dry lines as well as convective activity. To go back to what we were talking about with Africa, there's some coincident thunderstorm development that occurs both parallel and within 300 kilometers of the moist side of the dry line. Obviously, we know that moisture is pretty key to developing thunderstorms, and dry lines, despite their name, always have that one side of them that has quite a lot of moisture in the air. The research questions that I wanted to answer, as well as the hypothesis that I wanted to prove, are for the METARs that I had data for between 2014 and 2024, the highest differences in specific humidity and mixing ratio were associated with more reports of thunderstorms in the METAR, as well as I wanted to see if there was actually a dry line that sat in between Cannon Air Force Base and Lubbock International Airport, which, if you don't know, is about 100 miles to the east of Cannon Air Force Base. So I wanted to see if there was a significant difference between their specific humidities and mixing ratios. My hypothesis is that a dry line between Lubbock and Clovis, so higher differences in that specific humidity mixing ratio, would be correlated to the frequency of thunderstorm, TS, being reported in the METAR. So for my methodology here, I made a pretty important assumption, and that is that mixing ratio and specific humidity are essentially interchangeable, because what I'm doing here doesn't require a high degree of precision, and mixing ratio is essentially the ratio of water vapor over dry air, the mass of water vapor over the mass of dry air, which is really closely related to specific humidity, which is the mass of water vapor over per unit mass of the moist air itself, right? So it has that moisture in the denominator as well. And this is reflected in a bunch of literature. My main literature to back this up is Grant Petty's textbook that he wrote, but he talks about how the numerical values of mixing ratio and specific humidity differ by no more than 1 or 2%, and so in this project I will use mixing ratio and specific humidity pretty interchangeably, but my calculations that I have done in this project are born of the calculations to determine mixing ratio, not specific humidity. So I got all of my data. My data is from a 20-year period between 2014 and 2024, January 1st to January 1st. Iowa State University has a bunch of old METAR data that you can pull as an Excel file. So that sits at about 100,000 points for Cannon Air Force Base, and about 90,000 points for Lubbock, which is Lubbock International Airport. If you're wondering why there's like a big data discrepancy, there are a lot of reasons this could be. The main one that I believe causes this is, and this is knowledge taken from my application as a pilot at Cannon Air Force Base, is that Cannon Air Force Base is a training airfield, as well as a military base, as opposed to Lubbock International, which is obviously civilian. So there are always going to be more reports, more amendments to the METAR, because there are people that need to be trained, and there are more flights going out of Cannon Air Force Base, and therefore kind of more serious consequences to not having an up-to-date METAR. So additionally, I used Pearson's correlation to determine if the thunderstorms that were reported in the METAR are correlated to a specific humidity or mixing ratio of greater than 3 grams a kilogram. And this is just because I have seen Pearson's used prior with continuous sets of data combined with like a yes-no set of data, right? Obviously I was looking at mixing ratio values as well as if there was a thunderstorm reported or not in a data set, which is obviously a yes-no. All right, so here is, just to start out, a histogram of our specific humidity gradient, our mixing ratio gradient in grams per kilogram. And you can see that most of the time, for most of the data, that gradient is very small, right? That makes sense. These airports are not very far apart from each other, but it can get up to 20 grams per kilogram of a gradient between the two, which to me is a sign that there could be a dry line present during those days. All right, so in order to determine if, you know, the difference between Cannon Air Force Base and Lubbock International was significant, I did a 2-sample t-test with a confidence level of 95, which gave me a p-value of really, really close to 0, causing us to reject the null that Lubbock and Cannon have the same mean of specific humidity. And you can kind of see I listed out the means. Cannon sits around 6 and Lubbock sits around 7. This reflects what we've seen. Some of the previous literature review talks about how the dry line pretty commonly either bisects or sits really close to that border of New Mexico and Texas, and those two airports sit on either side of that border. Also, for the future, I have been using Clovis and Cannon interchangeably. If I continue to do so, just know that Cannon is the Air Force base and Clovis, New Mexico is the town in which it's located, but they sit right on top of each other. All right, my Pearson's correlation, I did it both for the airports individually, so like specific humidity at each airport, and then the difference in specific humidity between Lubbock and Clovis. I did Lubbock minus Clovis just to kind of make the values more positive, because Lubbock has, as we saw in the previous slide, a mean that is slightly higher than Clovis, which makes sense because it is more easterly, right? More, and therefore, from our analysis of the dry line, would be more affected by that Gulf air. So the Pearson's correlation for all three came back at pretty non-significant. Lubbock was the strongest one, had a slightly positive correlation, but this is not, to me, this is nothing that I would feel comfortable being like, it's strongly correlated. In no way is it strongly correlated. And in fact, I think that there's almost no conclusion we can draw from this, except for possibly a different way to do this research in the future. All right, so another thing I wanted to see is, of all of the thunderstorms reported in the METAR, if we just took those specific humidities, was the mean of those specific humidities greater than 3 grams per kilogram, which is the standard for determining if there's a dry line. And by that I mean the difference in between Lubbock and Clovis. And we find that it is. There's a mean of like 7.5 grams per kilogram. However, the standard deviation is pretty high. It sits around 10. And we see there's like a minimum of -14, a maximum of 35 about. So to me, this says that those two things are interlinked in some way. However, I'm not confident, as we saw before, to draw any sort of correlation to them. So one thing that I got from this project is that thunderstorms, like Tango Sierra being reported in the METAR, is actually relatively rare. I only found 4,000 of these instances out of 180,000 METAR reports. And I think in the future, I would analyze these events kind of synoptically, as well as from an overall perspective of like, what do the surface charts look like? What is going on in the upper atmosphere? We just recently had a really horrible set of thunderstorms here that damaged a whole lot of aircraft. I'm talking so many millions of dollars of damage from hail, and there was a tornado that hit a bit north of here. Taking that event, analyzing where the dry line is, I think that might have been a more effective approach to this scenario. And however, we did find that there is a high specific moisture gradient between Cannon and Lubbock. So I think more research is needed and more analysis is needed. But from our literature review and from what I found myself, I'm pretty confident in saying that there is a dry line that sits pretty squarely between those two airports. Well, I hope you enjoyed this. It wasn't everything that I expected to get out of this research, but I found it enjoyable, and my fellow pilots that I work with also think it's really interesting to talk about and very topical to everything that we go through every day. I will go through my references and just let me know through message if you have any questions. Thank you.